the technique of completing the square allows you to solve quadratic equations and also to determine the center of a circle or an ellipse or the vertex of a parabola. All right, the main idea in completing the square is to turn a quadratic equation of this form. You have ax squared plus bx plus c. That is standard form. And you want to change it to this form. You have a and then x minus h, all of that squared, plus k. This is what you would call the vertex form, where h is the x-coordinate of the vertex, and k is the y-coordinate of the vertex of your parabola. All right, one way to complete the square is to use a formula, and that formula is the following. You would have ax squared plus bx plus c equals ax plus b over 2a, all of that squared, minus b squared over 4a squared plus c. Okay, now this does look a little bit complicated. So instead of doing this, in this video we'll complete the square. That is a series of steps in order to solve for the values of x that would satisfy a quadratic equation. All right, so let's say you have this quadratic equation. Let's say you have 2x squared plus 12x minus 32 equals 0. And you have to solve this by completing the square. Okay, now right away you can see that you have the coefficients 12 and 32, and 2 is all the way at the left. All right, if you divide everything by 2, you're going to end up with nicer coefficients. However, let's refrain from doing that for the first step. Okay, so well, why you would not do that? Well, you would not divide by 2 first, just in order to demonstrate what you should do when the a value is not 1. Okay, so this is what you would do in general, because sometimes you're not going to have a quadratic that is as nice as that one. Okay, so the first thing you're going to do is you're going to add 32 to both sides. Why? Because you want to have that constant on the right side, right? Separated from the terms with the variables. So you're going to have 2x squared plus 12x equals 32, because when you add 32 to both sides, that's simple algebra. You get 0 on the left side and 32 as positive 32 on the right side. All right, okay, fair enough. Now what you're going to do is you're going to factor out the 2 from the expression on the left. And you can do that right away. You're going to have 2x squared in the inside of the bracket. Then you have 6x. Okay, and that equals 32. Okay, fair enough. Simple steps. You move the 32 to the right side, then you factor out the 2 from the expression on the left. Now the next thing that you're going to do is a little bit, well, it's not really complicated, but at first it might seem a little bit complicated. You're going to take the number in front of the x. I'm talking about the left expression, and the number in front of the x is 6. Right? You have x squared. The number in front of that x squared is just 1, but it's x squared. It's not just x. So 6, you're going to take that number, you're going to divide it by 2, then you're going to square that result. All right. So very briefly, 6 over 2, that's 3, and then 3 squared, that's 9. Okay, well, you have 9 now. What are you going to do with the 9? Well, you're going to add it to both sides. You're going to add it to both sides. How does that look like? Well, you have 2. You're still going to have that 2 on the outside of the bracket. Then you have x squared plus 6x plus 9 on the inside. Okay, well, look at that. You have a perfect square on the left side. A perfect square trinomial. That is going to equal 32, not plus 9, right? Because you have to have the values exactly the same on the left and on the right. If you expanded the trinomial on the left side, you're going to end up with 2 times 9 for that third term. you're going to have three terms that are adding each other, and that third term is going to be 18. Therefore, you're going to add 18 on the right side. You're still adding 9, but you're adding the 9 multiplied by the 2, right? So that's 18. All right. Now, you have a perfect square trinomial. On the left side, you're going to factor that out, and you can do that mentally. You get two numbers that add up to 6, and those same two numbers have to multiply to 9. Right away, you can think of 3, right? 3 and 3. So you're going to have x plus 3 squared. That's going to equal 32 and 18. What's that? That's 50. 50. All right. Perfect. All right. And this is looking very, very nice. You have a 2 on the left side. You're going to divide by 2 on both sides. Now you end up with x plus 3 squared equals 25. All right. And this is looking beautiful as well. Now you're just going to square root both sides. So you end up with x plus 3 equals, and now when you do square root of 25, you already know that's going to equal 5. But you also know that negative 5 times negative 5 is also 25. So in reality, you have two answers for the square root of 25 that you're going to consider. Positive 5 and negative 5. All right, so you have positive and negative 5. So you have two cases. You have x plus 3 equals 5, and you also have x plus 3 equals negative 5. So here, x is going to be 2. X is 2 here, and then x is going to be negative 8. All right, there you go. You solved for the x's of this quadratic equation. That is where the vertex is going to be. All right. Actually, no, that is not true. This is where the zeros are going to be. All right. If you plug 2 and negative x into the original equation, right, up here, you're going to get 0, right? Those are the two x's that satisfy this equation. There is another way to solve this, and that is using the quadratic formula. However, we're going to look at that in the next video.